Okay, this is part two, and I'm going to do this in two different videos. So this is how Millikan, this is one of the formulas Millikan used to measure the charge on one of those drops. So here's this drop, right? It's in here in some electric field like this, right? And this thing is some distance apart like this, right? There exists some voltage V, we'll use that, right? Across these plates, right? So we've got some source of voltage here. So we'll say like this, right? Like that. And then I'll put a line through that. That's a variable source of voltage. He just used a big resistor is what he did, right? So this is our positive plate like this. Here's our negative plate, right? And the basic equation is just simply that the electrical force up, right? If you suspend these drops, right? So that's what we're doing. We suspend the oil drop, right? If we suspend the oil drop, then the force, the electrical force, is equal to the force of gravity. Okay, well that's simple, right? The electrical force is F equals EQ, right? So this is the force that the electric field exerts on the charge, and then the gravitational force is mg, right? So ultimately we just set those two equal, right? We go mg equals EQ. Well, now we're going to substitute, right? This mass here, we don't just know the mass of it, but we can measure its radius. That's the third part here. Okay, so we can measure this radius, and the radius is related to the volume this way, right? The volume of the drop is 4/3 pi r to the third, right? And then there's a relationship between density and volume, right? And that is that density is a rho, Greek letter rho is mass divided by volume, right? Since we're already using a V for voltage, right? And then we'll also have a V for velocity, right? This gets very, very confusing, right? But suffice it to say that the mass of this thing is equal to density times volume, right? Okay, so now we're all set. We can set this thing up, right? The mass is going to be density times 4/3 pi r cubed, right? Times 9 times g, right? I was going to write 9.81, right? It's all over then. And then the electric field in there, if you recall, the electric field is the voltage divided by the distance, right? So now this V is our voltage, right? If we divide that voltage by that distance, we get the electric field, right? So that equals V over D times the charge. Okay, and now we have almost the formula you need to derive. Okay, so what you need to do is you need to solve this for Q. So you're going to take this thing, multiply by D, divide by the voltage, and make it a nice fraction. Okay, so your goal for this is to find Q, a formula for Q. Q equals something. Okay, you're almost there, right? D will be in the numerator, V will be in the denominator. You're done. Okay. The next thing I want you to do, and I'll show you this in the next video, is to plug in units. Okay.